Okay, let's set the scene. It's Las Vegas, January 2026, the Consumer Electronics Show,
CES.
CES. And if you haven't been, you have to just imagine this futuristic bazaar that is somehow the most exciting and the most exhausting place on Earth.
Oh, it is. It's loud, it's flashy, just pure chaos.
Total chaos. We're talking robot invasions in the hallways, AI promising to run your whole life for you.
Right, and wireless power systems beaming energy to door locks. I mean, it's straight out of sci-fi.
It is. But in the middle of all that noise,
Yeah.
the flying cars and the talking fidgets, there was one booth, one announcement that just stopped people dead in their tracks.
And it wasn't some flashy gadget you could hold.
No, it was a battery.
And not just any battery. If, and we have to put a huge if right at the top here, if what they claimed is true, this is the holy grail of energy storage.
We're talking about a small Finnish startup, and the name is great, Donut Labs. They, along with their partner Verge Motorcycles, made this announcement that sounded, well, let's be honest, it sounded impossible. They claim they have a solid-state battery that's ready for mass production.
And it doesn't just beat the competition, it humiliates it.
We're not talking about a 5 or 10% improvement.
No. These are numbers that kind of break the known laws of physics as we understand them.
So that's our mission for this deep dive. We're going to peel back the layers of this so-called miracle. Is Donut Labs about to win a Nobel Prize and change the entire global economy?
Or are we looking at a billion-dollar bluff?
Because the conflict here is spicy. You have tech fans who are just desperate to believe, and then you have major battery experts, physicists, basically screaming fraud.
It's that classic tension of innovation, isn't it? Extraordinary claims require extraordinary evidence.
And the evidence from Donut Labs is, well, it's complicated.
Very.
So let's start with the claims themselves, the impossible specs. Because when I first read these, I legitimately thought there was a typo in the press release.
It really does read more like a Christmas wish list than a spec sheet.
Okay, let's unpack this. First up, energy density. Donut Labs is claiming 400 watt-hours per kilogram.
Right.
For anyone listening who doesn't spend their life reading battery data sheets, can you put that in context?
Sure. Think of energy density as the size of the gas tank relative to its weight. A standard Tesla 4680 cell, which is, top-tier tech right now, is around 240, maybe 250 watt-hours per kilogram.
So Donut Labs is claiming nearly double that.
Almost double, yeah.
Twice the range in the same weight. That alone would completely disrupt the industry.
Oh, absolutely.
But then they hit us with a second claim, charging speed. They say this thing charges from 0 to 100% in 5 minutes.
And this is where the eyebrows really start to go up. In the industry, we call this the C rate. A 1C rate means you charge the battery in 1 hour.
30 minutes would be 2C.
Right. So Donut is claiming a 10C charging rate.
And the problem isn't just the speed, is it? It's that speed combined with that density.
Exactly. That is the fundamental trade-off in battery physics.
Yeah.
I like to think of a battery electrode like a sponge.
Okay.
If you want to store a lot of water, that's your high energy density, you need a thick, dense sponge. But if you pour water on a thick sponge, it takes time to soak all the way to the middle. That's your charging time.
Right. Makes sense.
Now, if you want to fill that sponge instantly fast charging, you make it really thin. But a thin sponge doesn't hold much water.
So you have to pick one, high capacity or high speed.
You have to pick one. Donut Labs is saying, we have a sponge that holds twice as much water as the best one on Earth, and it soaks it all up instantly. It's a contradiction.
But wait, because here's where it gets, for me, just truly wild. This is the number that made my jaw drop. The lifespan. They're claiming 100,000 cycles.
This is the biggest red flag. For anyone who knows the chemistry, this is a huge one. Let's put that in perspective.
Please.
The lithium-ion battery in your phone or your laptop, that's good for maybe, 1,000 cycles? Maybe 3,000 if you're lucky?
Before it starts to really degrade, yeah.
The best lithium iron phosphate batteries, the really durable ones they use for grid storage, maybe 10,000 cycles.
So they're claiming 10 times the lifespan of the most durable tech we have.
Even more. I mean, think about what 100,000 cycles means in the real world. If you put this battery in an electric car and charged it from empty to full every single day,
Every day.
that battery would last for 273 years.
273 years. You could hand that car down to your great-great-great-grandchildren.
Theoretically, yes, and that's why it's such a big deal. If this is true, the entire economics of energy just changes overnight. The replacement cost of batteries basically goes to zero. It changes everything.
But physically, a battery that degrades that slowly while charging that fast?
It's unheard of.
And they mentioned other wild stuff, too. It works from -30 Celsius all the way up to 100 Celsius with no degradation. It's non-flammable,
No toxic metals, no lithium, no cobalt.
which solves every single supply chain and safety issue in the industry. Just poof, gone.
No more thermal runaway fires, no reliance on conflict minerals. It's the whole package.
And get this, they say the material is clay-like. You can just mold it into any shape.
That clay detail is actually really important. We should put a pin in that for later.
What?
Because true solid-state batteries usually rely on ceramics. And ceramics are brittle, they're hard to manufacture. If it's like clay, it implies it's a polymer or maybe a gel.
No.
If it's a gel, you generally cannot get anywhere near that high energy density we were just talking about. Another contradiction.
So we have this miracle product that seems to defy the known trade-offs of physics. So who is the wizard behind the curtain? Let's talk about the founder, Marco Viitasaari.
Right.
I did some digging. He's not your typical white coat chemist from MIT.
No, he has let's call it a colorful resume.
He's a serial entrepreneur from Finland. But before that,
Mhm.
he was a Christian rapper.
Under the stage name Piku G or Kazi, I think.
Yes. And to be fair, he did have some success in tech. He created an app that SAP eventually bought for millions. And there's this great story where during the negotiations, he just threw out a price double what they were talking about.
And they took it.
They took it, added $1 million for good measure, and got it. So he knows how to sell a vision.
He definitely knows how to negotiate and value himself highly, that's for sure.
But he's also involved in, over 30 companies across Finland and Estonia. And reports say a lot of them have little to no actual business activity. But the thing that really makes you stop and think is what he was doing just 8 months before this battery announcement.
Ah, yes. The Azanoid project.
In May 2025, just last year, Viitasaari claimed he invented a super AI. He called it Azanoid. Said it had the combined intelligence of all the world's AI models, ChatGPT, Gemini, and Grok all, acting as a single brain.
Which, if true, would be the biggest software breakthrough in history. He's implying he solved massive AI problems in secret. And then less than a year later, he pivots from super AI to holy grail of batteries.
It seems like a pattern, doesn't it?
Yeah.
Just jumping from one huge buzzword to the next.
It definitely raises skepticism to revolutionize artificial intelligence and then 8 months later revolutionize material science to completely different, incredibly hard fields.
With a team of 9 people.
With a team of 9 people, it strains credibility to the breaking point.
So let's get back to the physics of it. Is this claim even possible? You mentioned the sponge analogy, but is there any tech out there that behaves like this? Something that charges instantly and lasts forever?
Actually, yes. There is one thing that fits the profile of fast charge and 100,000 cycles.
Okay.
It's not a battery, it's a capacitor. Or more specifically, a supercapacitor.
Ah, okay. I've heard this theory floating around. Can you explain the difference for us? What makes a capacitor different from a battery?
Sure. It all comes down to how the energy is stored. A battery stores energy chemically. Ions physically burrow into the electrode material.
That's called intercalation, right?
Right. And that physical movement causes stress and swelling, which is why batteries wear out. And it takes time, which limits your charging speed.
Okay, so batteries are chemical, time and wear and tear.
Exactly. A capacitor stores energy electrostatically. Think of it like static electricity sticking to a balloon. The energy just sits on the surface of the material.
So no physical burrowing.
None. And because it's just on the surface, you can grab it instantly. That's your fast charge. And it doesn't wear the material down, which gives you that long life.
So capacitors can explain the speed and the lifespan. What's the catch? Why aren't we driving capacitor-powered cars?
The catch is density. Surface storage takes up a lot of space, so supercapacitors usually have terrible energy density. We're talking 20 to 30 watt-hours per kilogram.
And Donut Labs is claiming 400.
Right. They're claiming the energy density of a top-tier battery, but with the speed and the life of a capacitor.
It's why everyone is so confused.
Precisely. And this gets us into the pseudocapacitor investigation. Some experts, like the Channel Zeroth, looked deep into the patents connected to this group. And there's real legitimate research into things like fiber-based supercapacitors using carbon nanotubes.
I saw the term nanotube forests, which just sounds incredibly cool.
It is cool science. The idea is you create this microscopic forest of tubes to massively increase the surface area, which lets you store more energy. And here's the trick. In the lab, If you look at just the active material, just the tiny bits doing the work, you can calculate really high densities.
But you can't build a car battery out of just the microscopic bits.
Exactly. You need the casing, the terminals, the electrolyte. That's the math problem. Once you build the whole cell, the real-world density just drops off a cliff.
So it goes from amazing in the lab to
Maybe 50 watt-hours per kilogram in a real device. Still nowhere near the 400 they claim.
So they might be taking a lab number for a tiny speck of material and pretending the whole battery performs that way?
It's a very common tactic in vaporware. Extrapolate a microscopic result to a macroscopic product and hope nobody checks the math until the investment comes through.
There was also something weird about the voltage, right? This one felt like a smoking gun to me.
Yes, batteries run on chemistry. Lithium-ion chemistry gives you a specific voltage, around 3.6, 3.7 volts. You can't just choose your voltage. Nature chooses it for you.
But Donut Labs claims the voltage is adjustable.
Like turning a volume dial, which is something capacitors do. Their voltage drops linearly as they discharge. But here's the kicker.
Yeah.
In their test footage, the open circuit voltage was sitting at 2.8 volts at 0% charge. That looks suspiciously like standard lithium-ion behavior.
But they said no lithium.
Exactly. So you have a voltage that looks like lithium, a cycle life that looks like a capacitor, and an energy density that looks like science fiction. Nothing adds up.
It feels like a puzzle where all the pieces are from 3 different boxes.
Yeah.
Let's talk about the proof. They were at CES, big splash. Did they actually show this thing working?
Well, according to journalists who were there, like Matt Farrell and the Electric Viking, no. At the booth, there were no working demos. No lights being powered, no charging demos. The batteries they had on display were apparently just empty shells.
So plastic casings.
Seemingly. And when they were pressed for data white papers, third-party testing, peer reviews, Donut Labs said it's proprietary.
That is the classic defense. We can't tell you because it's a secret.
It is, but in the battery world, you can prove performance without giving away the secret recipe. You can show the charge curve. You can let a third party verify the input and output. They haven't done any of that.
And there's a whole web of companies here, too. It's not just Donut Labs, is it?
No, investigations have linked them to a company called Nordic Nano. It looks like Donut is using tech spun off from them. But when a journalist asked Nordic Nano's PR director if the device was a battery or a supercapacitor, she refused to answer.
That seems like a pretty simple question. It's like asking a car company, is this a gas car or an electric car?
It should be. If you invented a revolutionary battery, you say it's a battery. If you're dodging the question, it suggests you might be redefining what a battery is to fit your marketing.
And we have to talk about Verge Motorcycles. That's the company founded by Marco's brother, right?
That's right. Verge is supposed to be the first customer. They've promised these miracle batteries will be in bikes shipping this March.
That's practically now.
It is. But Verge is reportedly facing its own financial crisis. There are reports that auditors from PwC PricewaterhouseCoopers couldn't even finish an audit because they weren't getting enough financial information.
That is never a good sign. When PwC walks away, you've got problems.
Big problems.
So what are the big guys saying? The ones who actually make batteries for Tesla and VW? Oh, they must be watching this.
They are, and they are being brutal. Sfolt, a major Chinese manufacturer, flat out called it a fraud. Their chairman pointed out that real solid-state tech is at technology readiness level 4 or 5.
Which means lab testing.
Lab testing. Donut claims to be at level 8 or 9 mass production.
So Donut is claiming they've leapfrogged billions of dollars of R&D from Toyota, CATL, Panasonic, with a team of 9 people in Finland.
CATL, the world's largest battery maker, also declared the invention clearly false. They know the physics. They know if you have a clay-like material, it's probably a polymer, and polymers generally can't handle the heat of a 5-minute charge without degrading.
So if it walks like a duck and quacks like a duck,
it's probably a supercapacitor trying to disguise itself as a battery. That's the leading theory among the skeptics. It might be a good hybrid, a pseudocapacitor that has decent performance, maybe even better than what we have now.
But not 400 watt-hours per kilogram.
Not even close. Or the other theory is, it's just a way to raise a lot of investment money.
The billion-dollar bluff.
Exactly. Raise $100 million on the promise of a miracle, and then maybe you can hire the engineers to actually try and build it later. We saw that playbook with Theranos. We saw it with Nikola. Fake it till you make it.
But the clock is ticking. You said March. That's a hard deadline for the truth.
That is the timeline. Verge Motorcycles says these bikes are shipping. If March comes and goes and there are no bikes, or the bikes that ship have standard lithium batteries,
then the gig is up.
Precisely. We're not waiting years for this one. We're waiting weeks.
So what does this all mean for us, for the listener who is just trying to figure out if their next car is going to charge in 5 minutes?
I think it's a lesson in skepticism. We're all desperate for this technology. We want the EV that charges as fast as a gas tank. We want cheap, clean energy storage. And that desire makes us really vulnerable to the miracle pitch.
It's that too good to be true filter. We want to turn it off because the promise is so, so good.
But physics doesn't care about our desires. It doesn't negotiate. That trade-off between energy and power is a fundamental law. Breaking it isn't just an engineering challenge, it's a scientific revolution.
And revolutions don't usually happen in secret, with empty shells at a trade show.
It is fascinating to watch, though. It's a high-stakes poker game on a global stage.
And we're about to see the river card. I want to leave the listener with a final thought. History is full of people who were called frauds until they weren't. I mean, the Wright brothers were called liars for years. But history is also absolutely full of people who promised miracles and delivered empty boxes. In a world that is, literally burning for better energy solutions, does our desperation just make us the easiest marks in the room?
Or is there a tiny, tiny chance that a rapper from Finland just beat the entire world to the punch? We'll know in March.
We certainly will. Thanks for diving in with us.
Always a pleasure.